Hello, good evening, everyone. My name is Eshan Rao. I am a PhD student from Indian Institute of Technology, IT Tirupati. Uh, can someone text me that whether they can hear me out or not in the chat box? Okay, thank you. So this is my fourth interaction session. I usually give this data analytics with Python interaction session on Friday, but due to certain circumstances, I'm giving on Monday as well. Uh, so what I have done in last 3 weeks is we discussed some aspect of pandas, and we discussed last time probability distribution. Probability distribution, basically a binomial distribution. This week I'm going to solve few questions in both in Python uniform and normal distribution. So I'm going to discuss few aspects of that, and I will solve these questions within these 2 hours. So the session has started recording, and few aspect of it is uh, like since it's 2 hours call. So around 6:50 or 7 we will take a break for 10 minutes, following by we will do our regular question session. If anyone has any doubts or something, please type it out in chat. While solving the question I might not able to see, but after solving the question I may look at those chats. Okay, so that being said, I will start with the Poisson distribution, and the reason I'm solving questions via hand is, if you observe that in third week you just have to use direct functions, and you have to give the values in their functions to calculate the probability of a certain function. But unless until you solve more and more questions, you're not able to understand which values you have to give at which place, and how it is going to calculate. So this session is mostly for the hands, in terms of the writing the stuff uh, and solving it by hand. Okay, and I'm posting one this file. This file is is the sheet on which I'm writing right now. I'm going to solve in this PDF file, so you can look at that also later. Otherwise, once the session is over, I will send, while I'm uploading this video, I will put the session this link of whatever I have written today along with that. Okay, so that being said, let's start the Poisson distribution. So I'm going to give the brief of Poisson distribution, followed by we'll solve some questions. Similarly for all the other distribution as well, because the binomial, Poisson, uniform, and normal, these are the most common distribution that you can see in probability, and you're going to and most of the question revolves around these kind of questions, these kind of distribution. Okay, now uh, for Poisson distribution, it is more like that you have an occurrence, you have an event, and in that there's some occurrences happening, and that occurrence is basically has an average rate, average value, that means doesn't change. So that's one of the condition. For example, a event is I have a highway, in that I have a petrol pump, and I'm just calculating that in an hour how many cars are visiting that petrol pump. Okay, so that's the event is that that the car should come to petrol pump, and I have an average rate or average number of cars is coming, and I just need to calculate that give for given hour how much cars make up. So these are this is a kind of condition we are setting for Poisson distribution. Now another important aspect of this is that they are all events are basically are independents. That means suppose my average rate of petrol pump of car is 2 cars, like on an average every hour I'm getting 2 cars on the petrol pump in the highway. That 2 cars is not going to affect me the next hour or the next to next hour. So at the 10th hour also, while starting this event also, it doesn't going to affect me because events are independent. So that means 10th hour of my observation is not going to affect my first hour observation. That's what we are saying when all events are independent here, and we are just using usually a count of events. So when we are saying that tell me that at fourth hour how many cars are happening, so we are going to calculate using certain probability. Okay, now so basically if we are saying that Poisson random variable, if we have this, so so in a question, in a particular random variable, we are going to say that in a particular Poisson random variable, it is just a count of the number of occurrence of an event. Okay, that's how we can define the Poisson distribution. And most of the question that you're going to solve is will be they will tell you that they have a Poisson observation. Now how they get to the Poisson observation and what is its relationship, Poisson relation with binomial or normal distribution, it is something we can see later. But and it requires more deep mathematics, so we are not going to venture into that, but I can tell you a little bit intuition about how Poisson and binomial distribution are similar to each other, and how Poisson distribution is just an extension of a binomial distribution. Okay, now uh, so for since it when we are saying Poisson distribution, we generally so this distribution is generally happen for discrete random variables. That means the random variables have a specific set of values. They are not infinite, and you can list out all those values. Okay, so even if they're infinite, you can list out all the values. Okay, so that's called like 1 0 or 1 200. You can list out all those values. So these are discrete random variable, and for that we generally for when we are trying to find a probability of those random variables, we call them as a probability mass function. Mass function we generally call for discrete random variables. For that, um, so for a Poisson distribution, so given a random variable small x, so for that it has been defined as lambda raised to x e raised to minus lambda x factorial, where lambda is mean, E is exponential constant, which is around 2.17 828, something like that. Okay, and x is the value that we are that the count that we are asking for a certain count of occurrence. What is the probability of that event? So for that we are having this small x. Okay, and another important part over here is for this is it works mostly on it works only for non-negative numbers. Okay, uh, so we will see that over the period of time that for normal distribution or uniform distribution we can also deal with the negative numbers, but here we are dealing with non-negative numbers. Okay, and standard deviation for this uh, variance is lambda, same as mean, and standard deviation will be underscore of lambda, I think underscore of lambda. Okay, so this is a basic overview for the Poisson distribution. Now what we will do, we will solve the quotient. We will see how we can make the quotient for probability using Poisson distribution. Okay, so the first thing is, so first question is plutonium 239 is an isotope of plutonium that is used in nuclear weapons and reactor. So it's a kind of element that we are having. Now in that they are asking that 1 nanogram of plutonium, 1 nanogram will be like 1 billionth of a gram. In that gram of plutonium 239, since it's a radioactive element, the average decay per second is will have an average of okay, it should have 2.3, I guess. I'm writing it down one more time. So average 2.3 radioactive decay per second, and the number of decays follows a Poisson distribution. So it's usually in the question you will find the Poisson distribution as it is. but here the average radioactive decay in the question should be 2.3. Okay, now the first question is, what is the probability that in a 2-second period there are exactly 3 radioactive decays? So, if you solve the first part of the question, we have a lambda of 2.3 radioactive decay per second. Okay, now and it is so it is being but per second. Okay, so we can't say this is the actual lambda, so we have to calculate lambda. This is the information is given, so we can't write like that. So we say it's a for 2-second period. So basically for 2-second period we just have to multiply it by 2. So lambda will be 2 into 2.3. So why? Because this is per second and we need a 2-second period. So we are calculating mean based on the 2-second period. So once we do that, so it will be like 2 radioactive decay per 2 seconds. Okay, now the question is that what is the probability that for if I get a for a 2-second period I will get a 3 radioactive decay from the plutonium 239. So for that the question will be like, if I have random variable of 3, so what is the probability of getting 3 radioactive decay? And x is a random variable that I am taking, that is for radioactive decay per 2 seconds. Okay, so if I do that, I just have to apply that mass function, probability mass function, that is lambda raised to x e raised to minus lambda and x factorial. So lambda I have 4.6 which I calculated uh, earlier. So I will like 4.6 raised to 3 into e raised to 4.6 and 3 factorial. Okay, now since these calculations are little expensive, you have to use calculator or they will provide calculator. Otherwise I have calculated here and it will be like 0.163. Okay, now another one more aspect that okay, first let me calculate another aspect as well, so then I will explain new another aspect of Poisson distribution. So it is asking me that, sorry, so the next question is, what is the probability that there are no more than 3 radioactive decays? Okay, so like within a 2-second period, on an average meet, how much whether I can get less than 3 radioactive decay or not. Okay, now for this, what how I have to write is like, it will be like x is which is less than equal to 3. This is how I should find it. Okay, and here I have to calculate for p x raised to 0, p x raised to 1, x equal to, sorry, x equal to 2, x equal to 3, p x 2 and x equal to 3. Okay, so this means is no radioactive decay, 1 radioactive decay per 2 seconds, 2 radioactive decay per 2 seconds, and this is 3 radioactive decay per 3 seconds. Okay, so since no more than that, so we are calculating each and every scenario with respect to this. So what we have to calculate, since if we put everything into this formula of earlier, of this formula, if we do that, so we will get the quotient of like 4.6 raised to 0 e raised to minus 4.6 0 factorial, 4.6 raised to 1 into e raised to minus 4.6 1 factorial, 4.6 raised to 2 e raised to minus 4.6 2 factorial plus 4.6 raised to 3 4 to 3 factorial. Now the calculation, if you do the calculation all behind it, the answer would be like 0.326. Okay, that calculation we are not going to do because it's complex and you need a calculator for like that. So we are going to do like this. Now one thing that I need to focus upon this, or maybe we can look at in some other question and while solving the Poisson distribution is as well, is that um, for a binomial, if I have a some graph like this, I'm just making a normal distribution graph, but let's assume that there is some graph like this and it follows a binomial distribution. Okay, so if it's follow the binomial distribution, if you have solved much questions of binomial distributions, you will find that you will have some n number of trails. So like if you're throwing a dice, it will have certain limit of trials. Tossing coin will have certain number of flipping of coins will be there. So this n trials is fixed in binomial distribution. But in Poisson, when it comes to Poisson distribution, there's no limit of there's no limit on trials. That means my upper bound can be infinity. My upper bound can be infinity. What does it means is, so for example, right now I'm flipping a coin. Okay, if I'm flipping a coin in a, so in binomial distribution, I may get that I flip the coin 15 times. Okay, and then I will find the number of head, uh, tail, something like that. Okay, but this thing I cannot map it to the Poisson distribution where I can flip a coin for infinite number of times, that is higher number of times, but at the same time I can't map it to the Poisson because there's no proper event that this not, it's not related to time, it's just related to trials. But how I can do is, like earlier question we said that in a highway I have a car which can go towards a petrol pump. Now that petrol pump number of events can happen for nth number of hours, and we are assuming that the average number of cars which are leaving from the petrol pump will be 2. So the distribution that we are going to make will be, can be upper bound, like we can continue that event for n number of times till we want, but the more number of upper bound will be there, that is higher the number, the less the probability of that will be get. So what does that mean is, so if let's assume this is my Poisson distribution. Since I will have some mean, so let's suppose this is my mean lambda is there. So since I have upper bound, that is no restriction of till what extent the event can go, maybe in terms of time or in terms of space or volume, on which usually the Poisson distribution usually calculated upon. Since it is moving away from the mean, the probability of getting that particular event happen on the upper bound will be low, and it is usually shown through graphs of a x which is way greater than x random, which is way greater than lambda. The probability will be reduced to maybe will be in 0.000 kind of like settings. So this is a kind of extension of from the binomial distribution that we can get in Poisson. So if I have to say mathematically in a sense, so it will be like, so if n, which is usually number of trials or in that in terms of event that we are having, the population sample, when n gets to infinity, p tends to get to 0. Now in binomial distribution we have the means at n dot p. So if this is getting infinity and p is getting towards 0, not exactly 0, so it will remain constant it can remain constant for the Poisson distribution. And that's how this binomial and Poisson distribution are related. Okay, so in Poisson distribution, n can be very very large, and p, which is usually for successful event, probability for a successful event, will be getting very very low. Okay, so this is how Poisson and binomial has been related. Any question till now? If you're thinking that you're not able to understand this, please let me know in the chat section, or you can unmute yourself as well. Okay, and another aspect of Poisson is it closely approximate. That means it will not give you exact answer for what is the probability in terms of like that you can may get till binomial also, but from Poisson and all that it will give a close approximation of binomial distribution. You can work out the same problem maybe by converting that to binomial, by mapping to binomial distribution. You may have big numbers, but it may not be as accurate as binomial because you have to do a lot of calculation there. So that's why Poisson distribution is coming to the picture. Okay, so this is something with respect to the relationship between Poisson and binomial. That is, in Poisson, n tends to be become greater, that is the upper bound tends to be infinity towards infinity, that is you can get more higher number, and the probability towards, if you have higher numbers, will tend to towards to 0, that is the probability will get low and low over the period of time. Okay, now that being said, let's again go to the new questions that we are with respect to Poisson distribution. So the question is, a small business receive on average 12 customer per day. What is the probability that the business will receive exactly 8 customer in one day? So since a day can be divided into multiple things, this can be mapped to Poisson distribution. So for that, if we just look at on an average, we are already given lambda as 12, and we are asking for that for random variable of 8, that is 8 random variable of customer in one day, in a day. So for x equal to 8, what is the probability of like that? So it will go down to this Poisson mass distribution, and since lambda is 12 and x we are it's 8, so if we apply this value here, and if you try to calculate on the calculator, you may get it around 1014, which is equivalent to 10.14%. So that means if the small business receive 8 customers, that means there's a 10% chance that 8 customers will come. It makes sense also because mean is 12, so it is on lower side, that is lower customers coming, so chances of getting lower customer is less, so that's why it is getting 10. So if you ask for 11 customer per day, it may if we ask for 11 customer per day, then the probability will be much higher. Okay, so one question we have. Okay, the reason why so one question, why we can't use binomial distribution here. One basic reason will be here that we don't have a success and failure probability given in this question. So what is the success of getting customer, that probability we should get, and what is the failure of not getting that we can calculate using that. So one of this probability should be given, based on that we might calculate this using binomial distribution. But since we don't know that success and failure, that's why we are depending on the mean of the population that we are getting. In this case, is 12 customer per day. Okay, so this is for one question. Another question is, okay, so another question is, a student receive on average 7 text message in a 2-hour period. So what is the probability that the student will receive exactly 9 text messages in a 2-hour period? and what is the probability that the student will receive exactly 24 text messages in 8-hour period. Okay, so for this again, let's start with finding that average text messages that we are getting is 7 text messages, and our random variable x will be like number of text messages, okay, in a 2-hour period usually. So and our timeline is usually is given in 2-hour period. So we have x is equal to, so for part A we are asking that whether the student will receive 9 text message within a 2-hour period or not. So that is here our random value will be x is equal to 9, and we just have to apply the value in this equation of Poisson mass distribution. So it will be like 7 raised to 9 raised to minus 7 and 9 factorial. So here the output will be again, okay, here the output will be 0.104. Okay, so I think I have miscalculated the other earlier question. So the answer here is actually it's not 0.14. It is actually it's 0.065523, which is equivalent to 6.55 percentage. Okay, I just wrote down answer somewhere else, so it's just I miscalculated here. For earlier question, the answer will be 6.55 percentage, which we have seen for small businesses, and for the student receive a text message. For part 1 question, we are getting that there is a 10.14% chance that a student will get 9 text messages in a 2-hour period. Okay, now for the part B, it is saying that what is the probability the student will receive 24 text message in an 8-hour period. Now to solve this, we have to define our mean value in terms of 8-hour period. So it can be done using the law of ratios, that is if lambda 1 raised to lambda 2 is time period 1 to t2. So we can ask in terms of like lambda 2 by lambda 1 t2 by t1. So it is like here our t1 is 2-hour period, lambda 1 is 7, and t2 is our given 8, and lambda 2 if we have to find. So we just have to find calculate the ratio between them. This is in this case is like 8 raised to 2, it is 4. So same cheese if we apply here, so we will find that lambda 2 will be 4 into 2, 2-hour period, that is 8 hour. Oh sorry, lambda 2 is not 4, lambda is 7, right, and 4. So we'll get 28. So on an average we will get 28 text messages for on an average for 8-hour period. This can be possible only in Poisson distribution, because we are saying that for an event that is happening, the average usually doesn't change over a period of time. So we don't change the average. That's why since 8-hour period is there is 4 times of 2-hour period. That's why we're just increasing the mean value also with respect to that ratio, that is 4 times. So if we apply that for the B part, that is what is the probability that the student will receive 24 text messages, that is here random case equal to x equal to 24. If we apply that for 8-hour period, it is x is equal to 24 for lambda raised to x e raised to minus lambda x factorial. In this case lambda is 28 raised to 24 e raised to minus 24 and 28 and 24 factorial. If we calculate it using calculator, it will be like 0.0601, which is equivalent to 6.01 percentage. Okay, so there's 6% of chance that a student will receive 24 text messages in 8-hour period. Okay, now the last question of a Poisson distribution. So the last question of Poisson distribution is a small business receive on an average 8 calls per hour. So we have a mean of 8 calls per hour. This is the lambda. And what is the probability that business will receive exactly 7 calls in 1 hour? At business will receive at most 5 calls per in an hour, and what's the probability the business will more than 6 call in an hour? So with these three questions that we are having here, so let's start with part A. Since we lambda has already 8 calls per hour, and our random variables is number of calls per hour. So in this case 7 calls per hour is there, so x is equal to 7, and if we apply that to this probability mass function of Poisson distribution, you will receive it as 8 raised to 7 e raised to minus 8 and 7 factorial. So which will, if we calculate this using calculator, it will be around 0.135, and it is equal to 3.95, 13.95 percentage. There's a 13.95% chance that that business will receive 7 calls in an hour. Now B question is P will be at most 5. Okay, now ideally if at most 5 we look on that, that means we have to calculate for x is equal to 0, that is 0 calls in an hour, random variable x is equal to 1, that is 1 call per hour, x is equal to 2 calls per hour. I am writing directly here P3, P4, 4 calls per hour, P5, 5 calls per hour. That is at most we have to calculate for all these things. Now directly instead of calculating for each thing, you have to you can simplify the maths here. So since we have lambda x e raised to lambda x square, so here x is changing all the time. So what you can do is you can just take e minus lambda out, and you can just solve this equation with multiple equation that you are having. So in this case you will have lambda is 8, so e raised to minus 8, and then lambda is 8, so 8 raised to 0, x is 0 in this case, and 0 factorial. Similarly 8 raised to 1, 1 factorial, 8 raised to 2, 2 factorial. This is for each random variable that I'm having. I'm like for random variable 2, I'm having 8 raised to 2, just like this. Similarly like that, if we have this, so this will simplify the calculation, and then if you calculate it, so it will come down to 0.1912, which is equivalent to 19.12 percentage. So that means there's a 19.12 percentage chances that a business will receive at most 5 calls in an hour. So that's how you can calculate for those scenarios. Third scenario is, what is the probability that the business will receive more than 6 calls in an hour? That is more than 6 calls in an hour. So in this case, ideally if we go by binomial distribution or something like that, if we solve multiple questions like that, we might assume that if x greater than 6, people make mistake that we have to find for x equal to 7 and plus p x equal to 8, but this is actually wrong. Sometimes we make mistakes like this because we assume that 8 is the number of trials max to max we are having. But as we discussed earlier, that Poisson distribution doesn't have upper bound, so we can't calculate like this. So how we should calculate is, we have to write that since the whole area under the curve of a distribution is 1, so we have to write 1 minus probability of x which is less than equal to 6. So we have to find for probability for at most 6 calls, that is from 0 calls to 6 calls, and then we have to minus that with 1 to get that value, that to get the how much what is the probability that the business will receive more than 6 calls in an hour. Okay, so if we follow this mechanism, right, so we can write directly based on our above p raised to p x less than 5. If you follow this mechanism, and we can, I'm directly writing this formula, that is e raised to minus 8, and here my lambda is same, that is 8, and but I have to do, for instead of till 5, I will need to do till 8 is to 6. So I will have another mechanism. So I will just write it at 8 is to 0 by 0 factorial, 8 is to 1, 1 factorial, 8 is to 2, 2 factorial. So wherever the x value is changing, that is the random value, that random variable value that I'm getting from the, and I'm directly substituting here, such that we can solve more question for other distributions. 8 is to 6 by 6 factorial. Okay, so this is for this e raised to, sorry, so this, the green highlighted box that we are showing, it's this is a probability of x less than equal to 6, that is at most 6 call that I can get in an hour. For that I'm just putting in, and I'm just subtracting with 1 to get that at how much call I will get, if uh, it can I, what is the probability that I can get more than 6 calls in an hour. So if I calculate this, so it will be around, if you solve the calculator using calculator, it will be like 0.6867, which is equivalent to 68%, 68.67%. So this much amount chances are there that you will receive more than 6 calls in an hour. Okay, so that's about the Poisson distribution, the question that we're having. If anyone has question with respect to this, please let me know in the chat. Otherwise, we will move towards the next part, that is uniform distribution. Okay.
Sir, I have a question.
Yeah, sure.
Sir, please show the
Oh, I should move over.
sir, when question.
Question. Okay.
Okay. So exactly 7 calls in 1 hour. This is the very nearer to the 8 calls per hour. Okay.
Mm-hmm.
And in the last question, that is 6 call or more than 6 call.
Hmm.
It has a means 8 crossing. Okay.
Mm-hmm.
So probability of a question is 13, which is very minimum. And
Exactly
in this,
13. Exactly 13, we are saying.
okay, and C is the maximum, that is a 63% is
Mm-hmm.
there.
Okay.
So why the difference?
Okay. Okay. Let me draw the graph and just take a hypothetical situation here. That graph will look like. Okay. I have a graph here, and this is a probability, and this is a random variables x, which is number of calls per hour. Okay, let's assume certain kind of graph is not normal distribution, certain kind of graph is there, and I'm getting an average of 8 calls. Okay, now one thing that you have to understand, that it's a discrete random variable, it's not a continuous. So I am actually not aiming to identify that, like suppose I have 7th call per hour. So it's not like that I'm calculating, just let me write, I'm not calculating this whole area. This is for continuous random variable, which we look for that. We are just we are just trying in discrete, sorry, in discrete thing, we're just trying to find out what is the value here. So in this graph, at 7th call, what is the value here? So maybe in this case it may be 13 point something there. We can calculate what is the probability of exactly getting 8 calls. At that point of time, we might uh, get some value more than that. Okay, but in the C part, we are saying that more than 6 calls. This is a 6th call, and since there is no upper bound, at that point of time we are trying to calculate all this area. So here we are trying to uh, assume that we are trying to calculate all this area. We are not finding area under the curve in this case also. We are just assuming, we are just having a summation of all the different kind of points that it might have, and it might have under this, and because of that this area will be higher chances that I might get a call. So that's why it comes down to 67 or 60 plus percentage. So okay, assuming right the 8 under mean, left side will be also 50, right side is also 50, like mm, okay, let me write this. This is the eighth call, right? So this is a mean. This part is a 50%, this part is also 50-50%. This is a 50-50 probability that there, that from eighth call whatever higher will be, it's 50%, and whatever less than that it has a 50% probability. So it's just that we are adding up here right now, and we are not calculating area under the curve. We are assuming that it is calculating its discrete points, whatever are they on the graph. Okay. Yeah. Okay, I think someone has question as well. Okay, could you explain the boundary details about Poisson distribution? Okay. Okay, so what happens in typical binomial distribution is, from there I will try to, we taken up this boundary discussion, that in binomial distribution questions that you followed and all that, it have a specific set of trials. So it has some boundary condition that it has happened only that amount of trials only, not more than that, not less than that. Okay, it has happened that much of trials, and in that we are trying to find probability of different kind of events that might happen based on the outcome that we are receiving. But in Poisson, what is happening is that criteria has been removed. So they are saying that instead of n trials, I can fixed trials. I can have trials with respect to infinite. That is going. It can be go till infinite number of times. I can do a particular event n number of times, and which is very large. Okay, so in that case of scenario, we don't know what is the end point of the larger number that we are saying. So here we are assuming some number called infinity. We don't know which higher number is there. But in binomial, we usually know that this is the highest number. That is, up after n number of trials, we have to stop. So we can't have n plus 1 trials also. We can't have that. So that is the difference between Poisson and binomial. Binomial will extend it, and that's what makes it a different kind of distribution, and it works on a different kind of variables as well. So usually see that we usually working on the time variable. Okay, or you if you solve more question, you might find weight or space, length, kind of those kind of variables, uh, which can have and which has been defined a certain way that it can be have a infinite number of things. But binomial distribution quotients or the concept will be restricted to only certain in a fixed range of numbers. So that's the difference. Am I able to do that, or its explanation went too lengthy? Please type out in the chat so I know that whether you're able to understand that or not. The boundary condition. Okay, thank you. Just a minute. Okay, so we will just discuss about uniform distribution, then we followed by a break. Uh, After that, we will solve questions on uniform distributions. Okay, it's quite easy to understand. It's easy to understand this distribution, uniform distribution. It is a okay. Now we are coming now. This part, uniform distribution and normal distribution, they works on continuous random variables. So to give an intuitive example of what is a random continuous random variable is that I am having a rain is happening. So we usually calculate them that how much inches of rain happened in a today or tomorrow or day after tomorrow or something like that, right? So we calculate in that terms. So if we are saying that 2 inches of rain happened, in a continuous random variable, we can also say that 2.01 inches of rain also happened. This is also valid. 2.00001 inches of rain also happened. This is also valid. 1.999 inches rain of happened. This is also valid. Okay. So if we are, suppose we are calculating that a difference, a random variable, that tell me that if we are saying that find me the probability that 2 inches of rain has happened. So this is very quite hard to define it in a normal settings, because we know that exactly 2 inches rate we cannot guarantee it. So it might have, there are infinite number between 0.1.9 to 2.1. So they can be infinite number, even 0.0.2.0 to 2.1, they will be infinite number. So in this kind of cases, we cannot take it from a discrete point of view where we are just taking its absolute value. That's where the continuous random variable come into picture, where what we are assuming that if I have a probability distribution, I, instead of taking the value on graph, that whatever the, suppose y-axis my is probability and axis I have a some random variable, and I have a probability distribution. In discrete, I will just take the points on the graph, but that is not going to happen for continuous, because it's, I have to give a proper interval. And suppose I have a proper interval something like this. In this, I have to, then I have to calculate the area under the curve. In this scenario, so whatever the it's called dense probability density function. So whatever density function we are having, it's mostly the calculation of area on the curve for a typical probability distribution that we have got from a typical question. Okay, so this is amount of continuous random, sorry, it's about the continuous random variable in uniform distribution. It is the constraint that we are having here is, okay, the constraint that we are having here is that's a major and only condition, that it has a constant probability within certain domain. Okay, so a typical uniform distribution will be like, I have a px, which is some probability on y-axis, and x some random variable, and suppose it is starting, I have a and b. So some starting value, some ending value of a particular thing within a certain interval. So I have this value. So you can consider that, suppose the inches of rain happen. So I can give a as 2 inches and b as 4 inches, something like this. It has an interval and it has infinite number of numbers in between them. So at that point of time, I'm getting this uniform distribution, and I will have a constant probability over that certain domain. So let's assume that maybe 1/10. This is a 1/10 chance that 1/10 chance that I have a rain happening, and which is producing me 2 to 4 inches of rain. So for that, probability is 1/10. This is a constant probability that I'm getting. So this is a condition for uniform probability. Another aspect of probability is that it is symmetric. So if I get a mean value here, so let's say mu, so it will be, so mu, median and mean they are same. This is another important aspect. And assume that if you have to calculate the probability of this particular area, so of this if this area, if you have to calculate that, we just have to uh, write for a, we have to define the interval, that within which interval that we are having, the probability of that area under the curve is usually 1. So assuming that, so since it is a kind of rectangle, we can define it as like height into width. Now height will be px, this height will be px, and width will be the difference between the interval, the points a and b. Okay, so if we write it as, it will be like, height will be px, that is a constant probability that we are getting, into b minus a. So the px will be 1 by b minus a. That I'm assuming that this is height, the area is 1. Okay, probability under the curve is 1. So if we have this, I'm just writing that it's like px is equal to 1 by b minus a. So this is called density function. It's called probability density function. Okay, this is there and its mean value. So if you have to find the mean value of this, we just have to add them and divide by 2, we'll get this particular value. So the mean will be mu is equal to a plus b by 2. So we can get the mean value of the x at the x-axis. If we get that, we'll get this. Now standard deviation is a little tricky. We are not going for derivation side, but it is like b minus a square by divided by 12. Okay, that is there. Now if they, let's assume a different scenario, which usually will get more in this uniform distribution, that you have a certain px value and you have x as a random variable. You already have a uniform distribution graph here. Now in this, I want to find a probability between certain c and d. So I need to know the area under this curve, in the under this. So how do we calculate that? To do that, the probability would be directly. I'm giving the what do you say, the formula without any producing something here, like d minus c by b minus a. If you apply this value, we'll solve this type of question where, yeah, I have a uniform distribution between a and b. I have to find for certain intervals c and d. How we can find that? So once we have this, we will solve this, and if you apply this directly, d minus c divided by b minus a, you will get the probability of a certain interval, and we will usually write it as, if you have to define for this, if I have to define the probability of function like this, I have to say that c, which is random variable x, which is between c and d. Okay, if I define like this, I need to use this formula, d minus c divided by b minus c. But a more easier method also we will see that while solving the question. Okay, another aspect of of this distribution is, particularly this distribution is, these are mostly an approximation. Okay, these are mostly approximation because we are directly using the formulas. We can also use integrals, integrations to find the area under the curve. If you find out, we can get more precise value. But if I have calculated for one instances, we found out the approximation is also quite it's quite near to the what we found using formula. Okay, so this summarize, uniform distribution has a constant probability within a certain domain, and you will usually get a graph mostly in this rectangular form, and this rectangular form area will be 1 because probability is 1 in that area, and using height into width formula, we can identify the probability density function, which is usually 1 by b minus a for a certain random variable x, and that too within a certain domain. That is, it should be between a and b. Okay, mean is a plus b divided by 2, and standard deviation is a little complex. It's like b minus a square divided by 12, under root of b minus a square divided by 12. That's how it is. Okay, so we'll take 10 minutes break, maybe it's 7:05. You can come and we can start solving uniform distribution quotients and followed by normal distribution. That's what we're going to do. And if you have any other doubts, we can discuss right now within this 10 minutes as well. So right now it's a 10 minutes break for you people. Okay, we will start the session in another 1 minute. Now, can you hear me? Can you hear me? Yeah, okay. Sumit, I think if you're not able to hear me, then you try to rejoin one more time. Maybe some issue with the Spoken network or something like that, because others can hear. If we can't listen, also, right?
Hello?
Hello.
Hello?
Try to rejoin, Sumit, if you can hear me.
Hello? I'm not able to hear you. Can you please say?
Okay. Okay. So let's start with the next question. Mostly the questions related to uniform distribution. Uh, so So the question is, you usually take a bus for work, and you have been observed that bus is uniformly late between 2 to 10 minutes. Okay, on any given day, how long you expect to wait, with what standard deviation, and if a bus is more than 7 minutes late, you consider that you will be late for work. So what is the probability that you're being late? So let's start with, if you uh, start answering this, let's start by making a graph with respect to this. Uh, okay, I think Sumit has some problem. So others can hear me, right? Okay, so so if we try to make it, since it's a uniform distribution, so it's like at 2, and let's assume it's a 10. So let's make a rectangle like this. We don't know till now what is this particular probability is there, so we'll try to find out that thing as well. Okay, so to first find out what's the probability px here, we just have to see the area under this curve. So what we can do is px is equal to 1 by b minus a. We just have to do this because that's the formula of density function that we are having, and here b will be 10 and 2 will be a. um, okay, so b is 10 and a is 2, and if we try to put here 10 minus 2, it will get 1 by 8. So this is the probability that we are getting, this constant probability that we are getting for this uniform distribution. Now from this, it is asking how long you expect to wait. So it is basically asking the expected value for this distribution. So for mu will be like a plus b divided by 2. That is the mean for uniform distribution. If you apply these values, that is 10 plus 2 divided by 2, it will you get 12 by 2, which is equal to 6. And 6, since it is terms calling in terms of minutes, we are telling mean as 6 minutes as an average value. So average uniformly late is 6 minutes for a bus to come. Now standard deviation formula is under root of b minus a whole square and divided by 12. So if you put these values, 10 minus 2 is 8, so 8 square by 12. If you solve this thing, it will come down to 5.33, which is across 2.31 minutes. That's the standard deviation value. If you just have to apply the values in this. So till now here we go. Now the question is, if the bus is more than 7 minutes late, what will you, and you, it tells that you will be late for work. So what is the probability that you are being late? So find that. So it is saying that, so let's say this is a 7. So we have to find the area under this, because it's usually between 2 to 10 minutes. So from 7 minutes to 10 minutes, we have to find the area under this highlighted region, the green highlighted region. So if we have to write it in a mathematical notation, that means you have to find the area under the curve of for the values for the interval between 7 to 10. Okay, so this is a restricted domains, which is restricted domain only. It's not like Poisson that you have infinite values. It's a restricted domain. In that domain only, you have a constant probability, constant probability value. So for this interval, if we try to directly apply the function value, that is d minus c by b minus a, that is, in this case, b was 10, uh, a is 2, and d is also 10, and here c will be 10, c will be 7. If we directly apply this, it will be like 10 minus 7 minus 10 minus 2, 3 by 8, and 0.37. This is one way of doing this. Or more simpler way of looking at it is also, like, you already know that what is what is the probability here. So you can just look it as height into width. So say a width is 10 minus 7, this part, and height is, we know that's 1 by 8, so into 1 by 8. If we do this, 3 by 8, and you will get the similar answer that we got. Okay, so that's how you can solve a normal uniform distribution function. Let's look for another distribution function right now.
Sir, the answer is
uh, z- oh, point, okay, so point from 0.37, sorry, I haven't explained this let me show it. So that for this interval, that after 3, that is a 37.5 chance, 0.37% chance that if a bus got delayed after a bus is coming after 7 minutes, that is there 37.5 chance that I will be late to the office, because that's a question that I am asking here. If the bus is more than 7 minutes late, you will be late for work. What is the probability that of you being late? So what I am saying that I am trying to find the interval of that, how much percentage of times the bus will come after 7 minutes. So that is 0.375. That means 0.375 times percentage, or 37.5% percentage time there is a chance that I will be late.
Thank you.
Yeah. Okay, so let's go to the another question. Okay, so the question is, okay, the amount of time a person must wait for a train to arrive to a certain town is uniformly distributed between 0 to 40. Okay, so that is usually it's given there. So the question is, determine the probability density function, and define the probability density function, and draw a graph of fx. Why did we find a standard definition? What does it signify? Okay. Okay. So the reason is, let me, first of all, the question is that themselves asking. Okay. So first of all, the question themselves, they are asking that we need to find standard deviation. And what does signify standard deviation? Usually signify that, let me change the color, that bus is usually is late between 2 to 10 minutes. That's the data that I'm having. And usually if we take a mean, that is 6 minutes. So the standard deviation is whenever the new data comes, how much it is deviating from the mean value. So that's what we find it using standard deviation. So how much the value is deviating from the mean value. For that we finding. Otherwise it's the question that they is directly asking in the question, the standard deviation.
Yeah, it means it will be between 3.7 to 8.
Uh,
This side, 2.1 and this side, 2.1.
why? How you come up with? Okay, uh, not like that.
It will be either side of 6 or
Like if we are saying 2.3 minute standard deviation is there, it's based on the uniform distribution that if okay. Actually the concept will come in normal distribution, but usually it's like I have a okay, if I have a graph, I have a mean, so the standard deviation from both sides will be 2.31, okay, and then into 2 if you do 4.62, something like that. So okay, so deviation, it's like since how much is deviating from a certain mean, right? So if I plot that in a graph, I'm looking at how far away it is going. So it's not about both side. Both side I may get that standard if a number is between 2.31. If I'm getting at this thing, so it will be like 6 6 plus 2.31. That means okay, just a minute. So if I have this, so I will just say that 6 plus 2.31 will be 8.31. We write in different color. This 8.31 and 6 minus 2.31 will be around how much? 3.79, something like that.
6 yeah, correct.
Yeah, so okay. Oh, that sense you're saying, but it can be expanded to more values as well.
That is second standard deviation.
Yes, yes, yes. Oh, yeah. In that case, yes. Oh, what you're saying is correct in that sense. True. Okay. So let's go to sixth question. So we have a train and it's uniformly distributed. So let me find it out. I have a certain px value and I have a x value. So it is 40. It's 0 minutes. So I have to find px value as well. So okay, so I directly did the dog graph of fx, but here it is will. So first of all, determine the probability density function. In this case, a value will be like fx is written, so fx will be like 1 minus b minus a, 1 divided by b minus a, so it will be like 40 minus 0 by 140. So this is my fx, and this is the area that I'm. This is the uniform distribution area that I am having. That is between 0 to 40. Okay, so a and b is done. So this is asking for density function, that is probability of that, and just draw a graph of fx. Okay, then the question is, what is the probability that a person must wait less than 8 minutes? So in uniform distribution, what I found is like it's better to draw a graph to get much better understanding. So if it is asking for 8 minutes, so let's see. So if I have this 1 by 40, I have 40, 0, and some 8 here. So I just need to find out what's probably must wait less than 8 minutes. That is, I have to find the area between 0 to 8. Okay, so if I find that, that is mathematically I can write it as a notation p, which is x is less than 8. Okay, so for that I just need to what I can do simply, rather than applying the value of d minus c divided by b minus a, that is this formula, b minus a, I can just look at this graph directly and I will check that okay, I have the width of 8, so I will just do like this. I have a width of I will just do that height into width formula. So it's like height is 1 by 4, 40, and width will be 8 minus 0, so that will be like 140 into 8, that is approx 1 by 5, which is approx 0.2. which is equivalent to 20%. So what is the probability that a person must wait less than 20 minutes, if less than 8 minutes on the station? It will be 20% chance. Okay. Now the question is, what is the probability that a person must wait more than 30 minutes? For to do that, let's again find it using this graph itself. So I have 1 by 40 px, and somewhere it is 30 will be there, and I have to find the area between 30 to 40. Okay. Now if to find this, I just need to calculate the width, this width and height, which I already have it. So let's write it mathematically here. That is P, which is x greater than 30. But though here I'm just writing like this, but ideally it should be like for earlier above also, that is between 0, 8, and here it's like 30 equal to less than equal to. You have to define that in the interval. I'm just solving it, that's why I wrote in a different notation. But ideally, what if I'm writing like this, the notation means like this. It's interval between 30 and 40, not 30 and infinite. Okay, so if I just find the area, that is will be like 30 minus 40 minus 30 into 1 by 40 will be 10 into 1 by 40, which is equal to 1 by 4, which will be equal to 0.25, or 25% of the time the passenger has to wait, must wait for more than 30 minutes. Okay, so this is there. Now the next question is E, that is calculate for the interval between P 10 to 26. Okay, now we are already having this thing, so let's do that. For E, let's form again a graph, and this 40, 0, 1 by 40. Now here I have somewhere 10, somewhere 26, and I have to find the area between this. Okay, so if I do this, I just need to find the area between this again. So I can write it like it's 26. Area will be width into height, like 26 minus 10 into 1 by 40. If I do this, 16 into 1 by 40, and if I calculate it, since it's a multiple of 8, this is 2 and this is 5, this is 2 by 5, and if we calculate this, how much I'm getting? Around 0.4, which is equivalent to 40%. So 40% time a person has to wait, if it is between 10 minutes to 26 minutes. That is there. Now the next question is little interesting, that is if x is equal to 20. Now if I try to plot here directly 40, 0, and somewhere it is 20. Now ideally it should not work, because like we have discussed earlier, for a continuous random variable we can't exactly get the exact point. Like for the inches of rain, we can't say that we got 2 inches of rain. It might be little less, little more than that. Similarly, for here also we can't find it. You can look at it in that way, or you can directly see how we are solving. We are solving using width versus height, and since it's just a straight line, we might have height, that is 1 by 40, but we don't have any width between them. So ideally its probability is 0. Okay, since we don't have any width between this because it's a singular point, and we don't get able to get that usually in that in a normal scenario also. So that's why we are giving probability x equal to 20 directly equal to 0. Okay, next point will be that if I have a p x which is greater than 45. Okay, so I need to find a time that if the train comes after above 45 minutes. So in this also, this is another anomaly that we are having, that usually we have a uniform distribution for till 0 to 40. For 45 minutes we don't have any information. So ideally, even though we have width at 45, we may start from 45 to infinity kind of thing, but we don't have any height because we don't know any probability in this area. Okay, so in this case the height will become 0, and since it's not inside the uniform distribution, we don't know how to calculate it, so we assign it the value as 0 right now based on the information that we are having. Okay, so I hope that is clear for this two anomaly. So it has to be when we are having continuous random variable, we have to get a value within certain interval. We should get in certain interval. If we don't get in certain interval, just like we get for x equal to 20 in this case, we'll get the answer directly at 0. And if we have a value which is outside the distribution and for which we don't have data, uh, we usually consider this probability as 0, or if we calculate by width versus height also, we can get this probability as 0. Okay, so the second last question is find the mean and standard deviation for this situation, for the question that we are having. So let me find it out quickly. So f is, we have to find mean and standard deviation. So if we directly apply the value here in this formula, we will get it. So here is like 40 plus 0 divided by 2 is 20, and here 40 plus 0 is like 40 square under root 12. So if you solve it, it will be around 11.547. It will be like that. Okay, and the last question is, this is interesting, find what is the 85th percentile of a given uniform distribution. So they want to know that, like, I have got a uniform distribution right now. I want to know what value will be there at the 85th percentile. So in terms of this meant, what will the k minute will be there if I have a 85th percentile is given for the uniform distribution. That means for 85th percentile, that means that's the top 80. He's a top 85th percentile. Like all the values, we will consider all the values which is less than 85th values, 85th percentile in this case. Okay, so let me try to explain through using graph. That will be much better. So if I having, let's make a little big graph. So if I having a graph here, and let's assume this is 40, 0, 1 by 40. Okay, so if I'm having 20 here, this will be considered a 50th percentile. If I am having 10th value, that is at 10th minute, I will consider all the values within then as 25th percentile. If I am having at 30, it will consider 70th percentile, and 40 will be 100th percentile in the uniform distribution. Now I want to get some value here which is at 85th. So that means I need to calculate all the value from 0 to till this point, till this 85th point, and I don't know what is the k value here. So I need to find this k value here to tell that from this point all the less value constitute to 85th percentile of the uniform distribution. So I need to find that. To find this, it again comes down to the value of area, that is area under the curve. So I will assume that this is my area under the curve. So area will be, since the whole area in this case is 0.5, we are assuming, because it's 85th percentile, because a typical uniform distribution area is 1. So we are assuming, we are saying that for 85th percentile, that means the area will be 0.85. So we have to assume that, because from that all the values are less than 85. Whatever the values coming within the 85, we are assuming all those values in this distribution. Now since it has area 0.85, we have this, and we have height into width. We just have to put this value. So height will be 1 by 40, and width will be some k value which we don't know. We have to extract this k value minus 0 from 0 to k. So that is the width. So if we try to solve this thing. So you can assume that 0.85 into 40 into k. I'm just putting this here, and if we solve this, the value will be around 34. So that means at 34th value, I can get the 85th percentile of the given standard uniform distribution. So from 34th value till here, whatever I'm having, it's a 85th percent of the value of whole distribution that I can get. Okay, if I'm looking at the 40th value, that means I can get the whole 100 percentile of distribution value. If I'm looking at from the 34th percentile, I can get 0.85 of the whole given distribution value. I hope this might be clear for you. Okay, considering we have less time, so I will skip this right now. This question, I will directly go for uniform distribution. You can solve that. If you don't have any problems, we can again come back. So let me complete this normal distribution also, and at least solve at least one question uh, before leaving to our homes. Okay, so normal distribution, it's look like this. It's basically a bell curve. We call it as, and we call as father or mother of all curves, uh, because this is statistically you can find this kind of curve in most of the cases. So when people try to identify many situations, for example this height, so if you try to generalize the height of of adults between certain range, you will mostly find this bell curve. Okay, if you try to find weight, you will find mostly able to, if you try to plot that into in a graph, you will mostly find this bell curve. Similarly, for commute between A to B point, you will find this kind of bell curve. Okay, so it's of all the distribution we usually term it as, because we found many cases which can be represented using this normal distribution. Okay, now based on this normal distribution, what people find an interesting observation. So what the observation is, apart from this bell curve, it's it's called empirical rule in the, according to the what Ramesh sir has been teaching. So it will be like, if I have this as a mu, this is the average mean I'm having, and let's consider this as minus standard plus 1 standard deviation and minus 1 standard deviation, and this is plus 2 standard deviation, it's minus 2 standard deviation, uh, like that. So what the value they found is, this area under the curve constitute for 68% of the population, 68.268 kind of population. Okay, this area and plus this area as well constitute for approx 95 percentage. I will make another diagram, it's better. 95.45 percentage. Let me make another diagram here. I have this distribution one. So this is mean mu. This is minus 1 standard deviation, minus 2 standard deviation, minus 3 standard deviation, plus 1 standard deviation, 2 standard deviation, 3 standard deviation. Now this account for 68% of the population value. This account for 95% of the population value, 95.45, and 3 from the mean. If you go for 3 times standard deviation, it will account for 99 point certain percentage, like 978 certain kind of percentage of value. This is an empirical rule that we have, you might have seen earlier. Okay, so based on this we try to solve, based on this value we can directly solve many questions. So how, when we say 64%, 68% value, that means if you try to divide into two, left side, sorry, right side will be around 34.134 percentage of population, left side will be, left side of the mean will be 34.134, that is it's divided equally. Now from 95, if I try to like whatever 95.45 minus 68%, whatever the value will be, and from that if I try to add it here, so it accounts for this area will be account for 13.951. This accounts for 13.951% of population. And if you add all this area from minus 2 sigma to plus 2 sigma, you will get the 95% of the value, percentage of population. Similarly, 2.14 percentage value, 2.14 percentage value. Okay, so like if you constitute or if you add all this percentage of value, you will get 99.9 something percentage of population. Okay, so this is a normal distribution. The reason why we are having this, because exactly you can't identify, this is also approximation. So we will see two different methods of solving a typical normal distribution value with certain formulas like the z score also we will see. So let's start with this first question. So the question is, the test score of physics classes 800 students are distributed normally with a mean of 75 and standard deviation of 7. So we got mean and standard deviation as it is directly. Now what is the percentage of class has test score between 68 and 82, 61, and then the question is how many students have test score between 61 and 89. What is the probability that a student chosen at random has a test score between 54 and 75, and approximately how many students have a test score greater than 96, greater than or equal to 96. So instead of applying formula, we can directly try to apply the graph here, the graph percentage value. So let's apply it here. Okay, so let's assume this is 75, the mean that I'm having. So I'm directly defining the mean. Now here I'm having plus minus sigma plus sigma. So I just have to add the sigma deviation, the deviation values from while adding or subtracting the mean. So here in this case, if I'm adding 75 plus 7, I will get 82. Here I will get 68. If I take it more lower, it will be like 89 and it will be 61. If I take this, so it will be like 96 and it is 54, and these certain values will be. Now based on the values that we earlier have formed in this like the 34.134% of population, let's try, I'm just writing it out again here to solve our question. So let me write it in a different way. So it will be like this part will constitute of 34.134%, 34.134%. This constitutes for 13.591%, 13.591%. This constitutes for 2.14. This constitutes for 2.14, and then it will constitute 0.135. This constitutes 0.135. Okay, so now the first question is okay. How you identify that the bell curve? Okay, I got two questions. Okay, Anaga, maybe we can answer that question later. Like I will try to answer that question later. For that, let's. I just saw that question. So Sumit is saying, how you identify that bell curve need to plot for this problem? Please explain. Okay, so it is distributed. If it is a normal distribution has by default the graph of bell curve. We can't say that for any other graphs. Like we can't say that for usually for binomial or Poisson also, but for normal distribution it's usually a bell curve. That's how we know that we have to plot a bell curve. May I know if those are random values, specific values? Okay, so whatever the percentage that I am writing here in red, they are the specific values which has been tried and tested by multiple people. So it is an empirical rule which is there in statistics, which tells about if I have a bell curve from mean, the distance between first standard deviation of numbers, I can get 68% of population. I can identify the 68% of population. So I just divided that 50-50%. So if I divide this, I will get these values. Similarly, if I go more far ahead, I will try to get more different. I will get more different values. That means this from standard deviation, it accounts for 95% of population. So I divided it accordingly, stack by stack. So if I wanted, I can again explain how I achieved this. Now the numbers in blue These are which I have calculated just right now, because I have a mean in the question is given as 75 and standard deviation is given as 7. So taking mean as this value, from there I will get 82 plus 7 82 and plus minus 7 68, like that. Okay, so should we remember those values? You can remember in a partial way. You don't have to remember exactly like 34.134. Just try to remember in a maybe don't even remember that, because I will show you another technique using which you can solve that. I'm just trying to solve, if you remember these values, how you can solve this more quickly. So I'm just trying to show you one way of solving this question. I will show you using z-score also, that is using standardization, how we can solve a normal distribution problem. Okay, so since we have this graph, we just what have to do is, it is asking the A question that find a percentage of class has a test score between 68 and 82. That means it is asking that what is the population that is between this. So it's just trying to know the percentage of class has a score between 68 and 82. So by just looking at this curve, we can identify that it has some 68 percentage of value just by looking at this graph. So let me write it down here. So if I have to plot it for the A, answer A, I can write it as notation as percentage of class is between 68 to 82 marks, kind of thing. So it will, from the graph I will get at 68.268 percentage. Okay, so I just need to know percentage of class. Just by looking at the graph I can identify that. Now the second question is, approximately how many students have a test score between 61 and 89. So that means it is trying to identify the area between, let me take different color, from here to here. So it try to identify that around this area how many students are there which has a score between 61 to 89. So for that first we have to find the probability of that region, that we can find it, and then based on that we have to calculate how many students will be there approximately. So for that, for B answer, let's take different. So the question is the number of students are there between 61 and 89 score text score marks. So for that first I need to identify the probability between this region from 68 to 89. So if I just add it from here value that we have written here, that is 13.519, 34.134, 34.134 plus 13.159591, it will accounts for around 95.45%. So this is a kind of percentage of values there. If I directly, what I can do, I can just write it as 0.9545, because I'm writing in terms of percentage. These are all percentage. Okay, these are not probability, these are all percentage, because probability is between 0 and 1. So if I want to know that how many students have test score between 61 and 81, I have a class of 800 student. I just need to do 800 into 0.9545 for number of students. This is a total number of students, and this is a probability that 95% probability that most of students have scored between 61 and 89. So if I just score this, I will get the value of around 60. Okay, sorry. 0.9545 into 800 is equal to hash number student. If I do this, I will get the value of 673.6, which is not a whole number. So we just round it off to approximate 764 students, which might have scored between 61 to 89 in the physics test. Okay, so this is one way of solving. We are just using the graph directly to find out certain values. Based on this, we're getting the probability, and from the probability, we are solving the question. Okay, another question is, what is the probability that the student choose at random has a test score between 54 and 75? So that means it has expanded more. So it is asking that from 54 to 75. Okay, so only this part. mm, this part. So from 54 to 75, how much students have, if taken randomly, what is the probability that score is between like that? So to do this, we just have to write, it like, see, notably we will write 54, the random variable between 54 and 75. We just have to calculate the probability between this, that is 2.14, 13.591 and 34.134. If we just calculate that, we'll get the probability of like that. So it's like 214, 13.591 and 34.134, which is account for 49.865 percentage, which is equivalent to 0.499%. This is the probability that I can get for a randomly chosen student which has scored between, what is the probability that if a um, 54 and 75? That's the question, right? The student chosen at random has a test score between 54 and 75. Okay. Now the question is again, approximately how many students have a test score greater than or equal to 96? So it is asking that how many students are there, which is, you see the right side of the highlighted part. So they want to know that how many students we can have in test score which is greater than or equal to 96. So to solve this directly, we see that its answer is directly is written here, that is 0.135. So what you can just directly do is, for D quotient, for Px is greater than equal to 96, we can just start it as 0.135 and number of students they want, so it's 800 number of students into 0.135, which we around calculate. If you do that, it's like 0.0779, which is equivalent to one student. So only one student might have scored greater than or equal to 96 according to the typical bell curve that we have. And this is all approximation. It's mostly our approximation we are saying. We can't directly take it as a real world standard. That uh, real value standard only comes when you have all the data and when you try to plot the data and you find that it's a normal distribution. In those scenarios, you will find this value, and that also depend on the mean value that you are having. Okay. uh, okay, now let's look at the last question of this session. Oh, basically let's look at the z score, just giving a brief concept of what z score is. So now you have seen that an earlier question we have this marks from 0 to 100 kind of thing, right? We have a bell curve for distribution like this. Now similarly we might have for different things, maybe for different heights, or maybe I have a bell curve of different heights, or might have a normal distribution of different weights, like that. So I may have to deal with a lot of numbers. So to simplify, basically to simplify those scenarios, we are usually converting the data into z using z scores. So what exactly a z score is, that suppose we have, in this scenario we have mu and then standard deviation, then minus standard, then minus 2 standard deviation plus standard deviation, like that. So what it exactly do is it just convert this whole values into the format of 0 to uh, in the x-axis of 0 to 3 and 4. So that means if you do standardization of data, the same data will be, you deal with that, your mean will be 0. From here your standard deviation will be terms at like 1 minus 1 minus 2, sorry, 2 minus 2 minus 3, 3, in just like that. So now you're dealing with small numbers, and that will help you to faster calculation. Okay, and now to find z score, you just have to use the formula of x minus mu. Mu is mean divided by standard deviation, that is this. Okay, so for example, I am having a height of 66 inches, and I have a of a particular population. I have a mu for that, and I have a standard deviation of 2 inches. So if I have to find z score for this, so I just write, so I will just write it here. So I may write as like 66 inches, and here 68, 64, 62, 70, just like that. Instead of that, like that, what I can do is z, that is, let's suppose for I need to find the z score value of 67 inches, and at that point of time I will just do 67 minus 66. 66 the mu that I am having. So for this value I am finding 67 divided by 2, so I will get 1 by 2, which is 0.5. So how I can represent here is, again, if I try to make a this thing, it will be 0, and 60 instead of 67 I will plot it as a 0.5, and it will be 1 here, it will be minus 1 here, just like that. So we will see that how we can use this this z-score to solve a normal distribution probability. Okay, this is the last part of the question, so we will try to quickly solve this. Okay, so the question is, your local pizza shop claims their large size pizza is 16 inches. If it's not there, then it is free, and either it should be at least 16 inches. So if it is not, you found that it's not 16 inches, they will give the pizza free, and the pizza is normally distributed, so it's a normal distribution with a mean of 16.3 inches and standard deviation of 0.2 inches. So first of all, we're trying to find out what is the probability of getting a free pizza, and the second question, what is the probability of getting lucky with pizza over 16.5 inches, and what is the probability of getting a pizza between 15.95 to 16.63 inches. Here we will use a concept of z-score and something called a z table, which is already calculated. So we're using those tables to identify the values. Okay, so let's start solving this. So we already have given that we have mu of 16 inches. Okay, sorry, we have a mu of 16.3 inches and sigma of 0.2 inches. Okay, so we are having this. Now, what is the probability of getting a free pizza? So the free pizza should be like, the first question will be like the random variable x, which is the size of the pizza. X will be the size of pizza, should be less than 16 inches. Okay, so instead of that, for this we can directly calculate the z-score. So z-score will be based on that 16 point, so we just have to calculate that x minus mu divided by sigma. So here x is x will be 16, mu is 16.3, and sigma is 0.2. So if we apply like this, so we'll get uh, 0 16 minus 16.3 divided by 0.2, it will be like minus 0.3 by 0.2, it will be around 1.5, minus 1.5. So we just have to, so we have converted this question of p x less than 16 to p z less than minus 1.5. Okay, now here we have to look out for the z table, which usually provided in the exam if they are giving you a normal distribution. So it is, this is a how you can see the z table that we are having. Now I got a z value of 1.5, minus 1.5, so I need to look from here. I need to find the 0.1.5. In this case, the 1.5 is here. I need to find the row, and since I don't have any other value, I will look for only 0.00 value. So this is 0.06. I don't need to calculate anything. So the table will be provided usually, and using that table we can directly calculate these values, and we can tell that, which is equal to probability of getting a free pizza is 0.668. That is approx maybe 6.68 percentage that you might get a free pizza. Okay, similarly we just have to, so the reason why we get the z value from minus 3.4, and there's another tape have from 0 to 3.4. So usually in most of the question, most of the bell curve, we our range of value will start from z minus 3.4 to 3.4. So that's why the z value has already been calculated. We don't need to calculate one more time. We can directly use this table to calculate our values. Okay, so this is another way. It's a more faster way of doing this. You just have to convert a quotient in terms of standardization form into z-score. So the next question is, what is the probability that of getting lucky with pizza over 16.5 inch? So it is saying that p x greater than the size of pizza should be greater than 16.5 inch. So first I need to calculate the z-score. So z-score will be like 16.5 minus 16.3 divided by zero point 0.2. So it will like 0.2 divided by zero point 0.2, which is equal to 1. So this quotient will be converted like x, which is greater than 16.5, will be converted to z, which is greater than 1. So I just need to find out the value for z, which is greater than 1. If I find it, then I will tell you what next thing I have to do. So if I go to the table, so at 1.0, I am getting this value is exactly 1 is this, I will get 0.8413. So let me write it here. So I am getting here it's like value of 0.8413 for z equal to 1. Okay, but how this value has been counted upon is like for the z score, that is here 1. So let's assume this. So the so when they are giving the probability, so they are taking from the left side from here. So it is taking all the probability values from minus 3.4, maybe more than that, minus infinity till 1. So the probability of getting a z-score 1 uh, will be like 0.8413%, like 84.13%. So all the values with less than that will become comes under within one value. Now, but we have a quotient that z value should be greater. So our focus should be the area above 1, that is this part. So what we have to do, we just have to minus with 1. If we do this, we will get the value of 0.1587. That is around 15.87 percentage chance are there that your pizza is greater than 16.85. So again, to tell this, when you are having a z-score, they usually take it from the left side, so it will add the probability based on that. So it is saying that till z-score of 1, I have a 80% of 84% of the population is residing within within z-score of 1. Okay, but based on quotient I am having that I need a value probability which is with z-score greater than 1. So I have to calculate that. To calculate that, I just need to minus, since all area under the curve is 1. So I just know value minus this, which should be written as pz is less than equal to 1. So 1 minus z less than equal to 1. If I get this, I will get the value of 0.1587. Okay. So why we must minus the z value from 1? Okay, that's what I'm explaining. Like when you're seeing this z value, it is starting from 0.34. If you can observe uh, this z minus 3 point value, it has a very it has very low probability value, the population, that's 0.003. So it is starting from like that. So if I have I'm assuming this has 0. So somewhere here minus 3.4 is there from here, and I found a z value as 1. So when I'm from the z value table, I will get all the values on the left hand side. So whatever the population I am having before on the left hand side, for that I am getting the value. So that's why when I having so when I found the value of here as 0.8413, that is for the left hand side population that I am having. But I need the population for the right. I need a probability for the right hand side. So for that I need to have to minus that value from 1. Then only I will get that. I hope you're able to get that. If not, I will repeat that again. Okay. So last part is, what is the probability of getting a pizza between 15.95 to 16.63 inches? So I just need to so I have this interval given. interval given, that is between this, I need to convert into z value. So if I quickly convert this, let me so I have this c part, that is 15.95. I have to convert this, and what else value I have, 16.63. 16.63. So for this, z score will be like 15.95 minus 16.3, I guess, and 0.02. So it will account for minus 1.75, and this will be 16.63 minus 16.3 divided by 0.2. It will be like 1.65. So the value of this will be converting from p 15.95 x to 16.363. I convert that to the z score value of minus 1.75 x to plus 1.65. So I need to solve this value. So for this, I need to identify the values here. So how can I identify the values? So let me do that in a different page. So I have this now, minus 1.75 z between, I have to find this interval. So that means in this scenario I might have somewhere here 0, so minus 1.75, and here 1.65, some values there. So I need to find the area under this curve. Okay, so I need to find the value of this, I need to value of this from z table, and then I have to just minus it. So let's find for z value for minus 1.75. So I have minus 1.7, in that 5 is there, so 5 is, I think, yes, this. So minus 0.401. So I'm minus 1.7 and minus plus minus 0.5, it will comes to minus 1.75. In that I have a z score value of 0.0401. So I'll just write it out here, 0.0401. Okay, and I need to find the z score value of 1.65. So 1.6 is here and 0.5 is here. If I add this, it will become 1.65. So here it is 0.9505. So I have just write z value of 1.65 is 0.9505. So I have to if I have to find area under the curve, I can directly subtract these values. In this case, I'll just write it here. So it will be like 0.9505. This is the probability that I am getting. So if I am having this, so 0.9104. So the question was earlier, what is the probability of getting a pizza between 15.95 to 16.63 inches? It will be 0.9104 or 90 or equal to 91.04 percentage that I will get a pizza between that range. Okay, so it's almost time up. So let me revise what we have done from beginning. So we start with Poisson distribution, which is a discrete random variable distribution. Based on that, we have solved few questions on Poisson distribution. Followed by, we look at the continuous random variables, which is uniform distribution and normal distribution. Uniform distribution is a constant probability within certain domain, and usually get this graph in terms of rectangle. And if you if you're able to make for a question, if you're able to make a graph, you can solve the question directly. Similarly, for normal distribution, you need to have some understanding of the values that you're having. So this is an empirical rule that having that usually for normal distribution it comes out to be a bell curve. In bell curve, this is some standard process of how the population has been divided. So if you're able to remember that, you can solve question very fast. Or what you can do it, you can convert a particular value into z-score using this formula of x minus u x minus mu divided by sigma. If z-score, if you find that, from the z-score you have to look up the z-score table, which usually will provide it. From that you can identify the probabilities of a particular question within a normal distribution scenario. Okay, so yeah, that's the end of the session. Thank you for listening. Next session, mostly I will go through maybe week 3, or directly I will jump to hypothetical testing. Okay, so I'm stopping this this thing, and I'm ending this call.